I don't have time to get too into this. Remember RADI. Roots. R is your roots. Let me just go, I'm sorry. Alright. Roots. Okay? That's your x-intercept. Remember, it's x minus your root, your 0, your x-intercept. Okay? Factor it out. Remember, if this is to an even power, if this is your x-intercept, it's going to bounce off. If it's to an odd power, like x minus x plus 2, it goes through. Okay, so you get a bounce or a tangency. So once you find your roots, you go down to one of the t's, which is for tangent. Because when it bounces, it forms a tangent. This is a tangent line, the x-axis, and it, okay, and it has a point of tangency. So that's tangent and bounce go together. So if you've got a factor, you factor your x minus your root. If it's to an even power, it bounces. If it's an odd power, it goes through. We come to A, asymptotes. Vertical come from the denominator, right? Same thing. If it's to an odd power, like x minus 3. 3 minus 3 is 0, so it's x minus, again, your 0 for the denominator, but it's not an x-intercept. But I'd have an asymptote at 3. If it's to an odd power, if this factor, x minus 3, that gives me the asymptote, oops. Here's my asymptote, let's say. If that is 2, make it 3. Okay, so there. X minus 3. 3 can't have 3, so x equals 3 is the asymptote. If this is squared to an even power, your graph moves together with it, or down together. If it's not, it moves, if that was to like an odd power, like 3 or 1, it moves opposite, okay? So when you do roots, that deals with tangent and bounce. When you get to asymptotes and you get to your denominator and you find out where your vertical asymptotes are, that deals with togetherness, okay? Will the graph move together around the asymptote, okay? E is end behavior. End behavior, okay? That's basically what? End behavior is your horizontal asymptote, okay? All right, so sorry about that. RADI roots. A is asymptotes, including holes. Remember, if your factors cancel out, it's a removal discontinuity, just a hole at that value. Asymptotes. Tangent or bounce, that's for the numerator. Even factors, even power bounce. Togetherness. Okay, if the factors in the denominator, if they're that cause a vertical asymptote, if they're an even power, the graph will move together like so. Okay, and be together. If they're an odd factor, then they move opposite. Okay, togetherness in behavior, and finally, y-intercept. That helps you out a lot. Okay? All right? Remember, okay, if you're not going to hit the horizontal asymptote until you're totally outside all of your vertical asymptotes. Okay? So I might have something like this, but this graph will eventually, once I'm outside these vertical asymptotes here and here, then it can seek the level, okay? Bobo-Botten eats DC. Bigger on bottom, 0, y equals 0. Bigger on top, no horizontal asymptote. Eats DC, exponents are the same, divide the coefficient, okay? All right. you'll probably have to go from a graph to an equation. Okay? Recognize the zeros, if it bounces, if it's squared, the vertical asymptotes. Okay? Is it together? Then it'll be squared and so on. Okay? Come up with an equation. Do you have a horizontal? If you have a horizontal asymptote other than y equals 0, exponents are the same. You should have x cubed over x cubed, x squared over x squared. All right. Solving. Let me see a time check here. Holy moly, 5 minutes. All right. Remember, all right. Here's when we solve for these equations. One thing to remember, your answer like here is from 0 to 360. That means I don't want negative 50. That my answers need to be, solutions need to be in a specific interval. Or 0 to 2 pi. That means I want radians. All right? Here's an example I worked for one of my, let's try to get this. Okay? All right. Sine cubed minus sine cubed theta minus sine theta equals 0. I need to factor this. I have common factors here, sine and sine. So I'm going to factor out a sine theta times what? Sine squared theta minus 1 equals 0. Now this isn't simplifying. There's no identity here. We're solving. So either this equals 0 or this equals 0. So if sine of theta equals 0, then sine inverse of 0 equals what? Sine squared. Now I'm showing you this one because you've got both things here. If you plug in sine of 0, you'll get inverse sine of 0, you get 0 degrees. But where else is sine 0? Where else is y 0? So on that x-axis. Here, 0 and 180. Okay? I'm not going to put 360 because I've got parentheses here, not brackets. So just 0 and 180. Okay? Now, sine squared theta minus 1 equals 0. Add 1 to both sides. Sine squared theta equals 1. And we'll square root both sides. So, you move up here, guys. So we'll do some blue here. Okay? So sine, I take the square root of sine squared theta and 1. I get sine of theta equals plus 4 minus 1. Okay? We look out here, that's only 2 angles. But if that was like square root of 2 over 2, that's 4 angles. You've got 2 quadrants. Anyway, let's look at this. So we'll do inverse sine of 1 gets me, where's sine 1? It would get you 90 degrees or pi halves. Inverse sine of negative 1, so that's 1, sorry. So let's do inverse sine of negative 1 is going to be where? 270, or 3 pi halves. Okay? All right, and just for grins, let's say you have sine, you square root both sides, you get sine x, sine squared x equals 9 over 36, you square root both sides, sine of x equals 3 over 6, or 1/2. And it's plus or minus, you square root. So basically, you're going to go ahead and inverse sine of 1/2 and inverse sine of negative 1/2. And so remember, that's 30 degrees. So I'm going to have a 30-degree angle. Where else is sine positive? Over here with a 30-degree angle. Okay, so I'll have 30 and 180 minus 30. I've also got to do this. Inverse sine of negative 1/2 is going to tell you negative 30. There's negative 30. Where else is sine negative? Over in quadrant 3. Okay? So sometimes when you square root, you get plus or minus, you're going to get up to 4 angles. This one that we did with 1 or negative 1, and we lucked out because that's right on the pole there. You only got 2 angles out of that. All right? So the rest of these things, know your trig identities that you've taken, review the previous videos, all the identities, the 3 Pythagorean identities and all the cotangent reciprocals, they're all on there on the videos, okay? You should have them in your notes by now, okay? Just simplifying the trig functions, okay? I wanted to kind of go review this, and that's probably about all the time I have. Okay, that's 10 minutes, so just remember, solving, verifying. This is some of the verifying, and again, it's all about knowing your trig identities and knowing we worked these today and Friday. If you have any questions, watch the video, look at the notes. Substituting cosine x over sine x for what? Cotangent. Break everything down to the simplest form. Okay? All right, that's all I've got. Be ready to go tomorrow. Okay? Thanks.